Hey guys, what's up? It's your boy Trix. Today we're going to be doing another play framework stream where I'm going to be doing Akka actors quick start with Java. So, I'm trying to find a good place to put this. I think there is okay. Hopefully you guys can all hear me properly and clearly and whatever. Anyway, so it's a toolkit and runtime for building highly concurrent, distributed, and fault-tolerant event-driven applications on the JVM. Akka can be used with both Java and Scala. This guide introduces Akka actors by describing the Java version of the Hello World application. If you prefer to use Akka with Scala, switch to the Scala guide. I'm gonna be doing Java just because I want to do Java. But you never know, I might touch on this again if the roadmap.sh has Scala. Let me... Scala. Nah, it doesn't have Scala yet. But it does have Rust. Interestingly, not showing it. Java. Java's there. Rust. Rust isn't there. I know Rust was here a while ago though. Interesting. Fair enough then. Is it on a different page? No, for some reason the Rust one isn't here. Anyway, we're gonna be doing the Java one. So we're going to be doing Java. But you never know. When I get around to doing Scala, I'll probably do Scala with this again if I do find a roadmap with it. I'm planning to do Java first because I'm currently working with Java, but I'm doing like Rust on the side because Rust is the most popular language on Stack Overflow, like pretty much every year for the last 4 or 5 years running. So I've been learning Rust. Pretty cool language, by the way. And then after I finish the massive tutorial that I found with Rust, I'm probably going to move on to, I think it's Erlang or Alexa. It's the next one down. I'm going to do it by most loved to least loved, which is why Java being one of like the least loved languages, I'm like, I'm currently working with it, so I might as well do the roadmap with it. So yeah. So hopefully you guys enjoy that. Anyway, let's get back to this. Let me just get my BRB screen ready in case someone pops in. Actors for the unit execution in Akka. The actor model is an abstraction. Sorry, I'm just realizing this is very in my face. That's alright. The Akka actor model is an abstraction that makes it easier to write correct concurrent, parallel, and distributed systems. The Hello World example illustrates Akka basics. I'm realizing there might be some terms that people might not know. And if you found my channel, you probably know these terms anyway. But for people that have just stumbled across my channel and don't know what these are, abstraction is just saying that something has been simplified to the point that it's easier to use, kind of. Like, say for example, you have a good abstraction to think about is like, say for example, you have lots of car models, right? Like Jaguar or Ford or Nissan, or like car makers, right? So they will all have like their own type of car, right? But an abstraction of that would be just a car. So if you're thinking about in like programming, if you have like objects, you'll have the individual car types, and then they will all come from a superclass or abstract class called car that just has like wheels, doors, and stuff. And all the other ones would, and like some cars might have spoilers, some cars might have like self-driving and stuff like that. Those are the custom implementations of that abstracted class. Concurrent and parallel. Concurrent basically means executes one after another. Parallel means executes together, like at the same time. And then distributed systems are like, say for example, a good one is like servers. Like, say for example, Google, right? If you have like a CDN, if you make a request to a Google image, that image could be cached somewhere else, right? But even though it's cached somewhere else, you will make a request at one server, and that server will still be able to serve that file to you because it's like cached in a distributed network, so that network would be able to tell that server that, oh, it's stored here, you can get it from here. We'll be able to tell all the other servers you can get this from here, and then that server would find that in its like logs or whatever, and then just serve it back to you. What else? I think that's all. Fault tolerant is like if a system were to go down, you would be able to recover without any like downtime. That's like it's a very technical-ish answer. It's like, say for example, you listen to Spotify, right? If you listen to Spotify and you click play, you never have to think that, oh, this song just won't play. Fault tolerant would mean that that song is stored somewhere, right? Like everything is stored somewhere, like on a server or something. A fault tolerant would mean that if that server were to go down, there would be some type of backup that could serve it to you. That's what fault tolerant is, that there's always a backup that could do it, that could always be used in a scenario for anything. That's what fault tolerant is. Within 30 minutes, you should be able to download and run the example and use this guide to understand how the example is constructed. Well, that's a stretch. It might take me like an hour, but we'll see how it goes. This will get your feet wet and hopefully inspire you to dive deeper into the wonderful sea of Akka. I don't know if I'm pronouncing it correctly, but I'm gonna go with Akka. If that's wrong, please correct me in the comments or the chat. After trying this example, the comprehensive getting started guide is a good next step to continue learning more about Akka. I've got these other ones that I'm going to get through, so we'll see. The Akka platform guide discusses more Akka concepts and features and gives you an overview of Akka as a toolkit. My phone is getting squashed in this chair, sorry. There we go. I got my new phone, by the way, and my other phone is just sitting in a box. I installed LineageOS on it, and I think I talked about this in the stream before. I installed LineageOS on it, and Google Pay and some other banking stuff just stopped working, so I got a new phone. And eventually, when this one dies in 5 years, I will have to get a new phone, or I'll try to see if LineageOS is any better on this, where hopefully Google Pay and stuff will work and it'll pass safety net. I hate safety net, by the way. I want to reiterate, I hate safety net. I hate safety net. There we go. It had to be said 3 times. But we move. Hopefully this phone lasts a bit longer. I bought this basically as soon as it came out, so it should be alright. But it does suck that phone, like my OnePlus, is still kicking, going strong. Everything's fine with it, just doesn't get any security updates anymore, and that just sucks because it's still a good phone. It could be supported way longer. Like, I understand, because like buying an old phone doesn't really give you any more revenue as a company, that you won't be like making a lot of money from people buying your phone, because most of the time they're just buying it secondhand for cheap, right? No one's going to be paying full price for your phone, so you basically if you make that phone anymore compared to like just releasing your new phone, you're basically earning nothing. If anything, you're losing money. But software support shouldn't be an issue. I purely believe that software support shouldn't be an issue. Like, you could genuinely support phones for like years to come, like a couple years, like 5 years. 5 years fair, but you could support our phone for quite long. Whether it will be working like well, like handling new software and handling the OS and no slowdowns, optimizations for battery, that's a completely different story. But just releasing security patches, not that hard. Anyway, a real example for Java is zipped project that includes a build file for Maven and Gradle. Nice, they understand that people use Linux like me. The only prerequisite is Java 8 and installation of Maven and Gradle. That's fine. I'm gonna grab this. That took a while, didn't it? Let me just save this. Let me open up a terminal. My keyboard feels very far away from me today. Sorry. Let me just put that there. There we go. I'm a bit close to the screen, but you'll probably see me better now. If I CD into there we go. Unzip this one? Nah. Unzip what's there? Akka. There we go. rm akka quickstart.zip. CD into Akka. There we go. So I'm going to use Gradle because I like Gradle. Let me just... Oh, I was using SBT. Do I need to SDK in this? This? No. Let's see if Gradle will work. I don't like using SBT, it's slow. Any people that do like SBT, I have nothing against you. It's just I particularly do not like SBT. I actually want to see what the SBT files do look like, because I've never seen an SBT file before. I have seen Gradle files before, and Gradle files just look like, it just looks like Java and Python kind of mixed, so you'll basically understand it quite easily. With Maven, I just don't like that it's very verbose. Like with Gradle, everything's kind of concise, and like you can hack on Gradle very easily. With Maven, you need to know your tags in XML, or you're not gonna have a fun time. Let me just cat that build.sbt. Yeah, that looks fine. Weird library dependency syntax there. They're getting around using for reference, the way you could do like load library dependencies in normal Gradle is you could just do like whatever. Would have been nice if I just done whatever colon, and then this is all inside speech marks, by the way, so you'd be able to do that. Then you'd be able to do dollar, what is it? Let's do the first one, for example, right? Like 916, com type safe Akka. Then instead of those percentages, it'll just be colon, and then the package, and then colon. And instead of doing the percentage Akka version, you could just do in speech colon dollar Akka version, and I'll just grab it. I think you might need this. It's been a while since I edited a Gradle file. I just remember that you can like populate it inside the string and like do some type of string interpolation where you don't need to do these percentages, but doing is fine. If you do a Gradle, let's have a look. I don't know if it'll be okay. Because it does recommend Java 8, but I'm running Java 19 right now. I'm running Java 19 just because I was like, ooh, Java 19, I haven't used it yet, I want to see how it does. It should be fine, everything should be on the class path anyway. It's just like sometimes things are a bit weird with like Spring, where it can't find a dependency because that dependency doesn't exist in the latest version of Java, which is weird because the package version should still be the same, so it should be able to find it, but hey ho, what can you do? Yeah, that looks alright. Hello Charles, greetings from Charles. Yeah, that looks alright. Example consists of 3 actors. Greeter receives commands to greet someone and it responds with greeted to confirm the greeting has taken place. A greeter bot receives the reply from the greeter and sends a number of additional greeting messages and collects the replies until a given max number of messages have been received. The guardian actor that bootstraps everything is the greeter main. Benefits of using the actor model. The following characteristics of Akka allow you to solve difficult concurrency and scalability challenges in an intuitive way. Event-driven model. Actors perform work in response to messages. Communication between actors is asynchronous, allowing actors to send messages and continue their own work without blocking to wait for a reply. That's pretty cool, actually. I wonder if they have something like a queuing system, kind of like Kafka, where like, if you send in an event, if it's not received immediately, that event could like disappear. So what you do is you would queue up those messages, and then eventually, like the system that like processes that queue will tell you when it will be ready to receive another message. Well, I'm guessing that's how it would work, right? Because if it's asynchronous, it. Oh wait, no, it does have blocking. It doesn't have blocking, so. I do wonder how that works then. Strong isolation principles. Unlike regular objects in Java, an actor does not have a public API in terms of methods that you can invoke. So its public API is defined through messages the actor handles. This prevents any sharing of state. Sorry, I got the hiccups. Between actors, the only way to observe another actor's state is sending it a message asking for it. Location transparency. The system constructs actors from a factory and returns references to the instance. Because location doesn't matter, actor instances can start, stop, move, and restart to scale up and down, as well as to recover from unexpected failures. With this isolation principle, the bit that is interesting to me is this bit, because technically there could be a point where you would ask the actors, like two instances could ask the actors for its state. It would send that its current state is like free or something, and receive both, and then one could be missed. So I wonder how it handles race conditions like that. Location analysis. Actors start, move, and restart to scale up and run. That's very nice. Nice. Each actor defines a type T for messages it can receive. Case classes and case objects make excellent messages. I said excellent. Sorry, excellent messages since they are immutable and have support for pattern matching. Something we will take advantage of in actors in the actor when matching on the messages as received. The only problem with that is pattern matching is kind of slow. Like if you do a regex search on something, regex search is really nice because you can have multiple things to match on, right? Without having to do like lots of function calls or something. It will just be able to pass in the string of regex and do a matching on the pattern that you put in, right? And you can have multiple patterns there. But the problem with that is it has to pass each character individually, see each collection group pattern matching group that you want to match on, and then execute the logic around it, right? So you could have like multiple clauses with regex. You would have to do each individual one with the data that it's already collected, one after the other, which makes regex kind of slow sometimes. And if it's doing that on each message, that could make it very slow. Unless there's some type of model that they're using so that the regex that is passing is faster, because like normal regex in Java is kind of slow. But compared to if you're using like a dot contains or something, it's probably fine. But like if you're doing like proper regex with like long matching patterns, it's gonna be slow. So I wonder if there's like a recommended limit for the length of the matching pattern you're using. When defining actors and their messages, keep these recommendations in mind. Since messages are the actor's public API, it's good practice to define messages with good names and rich semantic and domain-specific meaning, even if they just wrap your data type. This will make it easier to use, understand, and debug actor-based systems. Well, yeah, if you're using like a data pipeline or something, you want everything to be readable so that you know in the future what it does. Use descriptive variable names, guys. Messages should be immutable since they are shared between different threads. That's fair enough. It's good practice to put in actors associated messages as static classes in the abstract behaviors class. This makes it easy to understand what type of messages the actor expects and handles. It is good practice to obtain an actor's initial behavior via a static factory method. Interesting. I wonder what type of. I wonder if they have an example of this factory. Let's see how the implementation of a greeter, greeter bot, and greeter main demonstrate. Following snippets from greeter.java implements the greeter actor. Okay, so let me just. I'm gonna pop open VI because I don't think it's gonna ask me to like edit the code. SLC main Java example greeter. I hate when this happens. There we are. So that's greet, whom. Then it has an actor reference to greeted, which is a reply to. Actor ref greeted reply to. I'm guessing that this actor reference could be like an atomic reference, because if it's being accessed by multiple threads, you want an atomic reference that it would potentially not lock, but it would make it thread safe. This small piece of code defines two message types, one for commanding the actor to greet someone and one that the actor will use to confirm that it has done so. The greet type contains not only the information of whom to greet, it also holds an actor ref that the sender of the message ref supplies to that greeter actor can send back to the confirmation message. The behavior of the actor is defined as the greeter abstract behavior with the help of the new receive builder behavior factory. Processing the next message then results in a new behavior that can potentially be different from this one. The state can be updated by modifying the current instance as it is immutable. In this case, we don't need to update any state, so we return this without any fields updates, which means the next behavior is the same as the current one. The type of message handled by this behavior is declared to be of class greet. Typically, an actor handles more than one specific message type, and then there's one common interface that all messages that the actor can handle implements. On the last line, we see the greeter actor sends a message to another actor, which is done using the tell method. It's an asynchronous operation that doesn't block the caller's thread. Since the reply to address is declared to be type actor ref greeted, the compiler will only permit us to send messages of this type. Other usage will be a compiler error. Interesting. The accepted message types when the actor together with all the reply types define the protocol spoken by the actor. In this case, it is a simple request reply protocol, but actors can model arbitrarily complex protocols when needed. The protocol is bundled together with a behavior that implements it in a nicely wrapped script, the greeter class. So this is greeter bot. Okay. So greeted create int max. That's a lambda I don't like. Lambdas make I was about to say atomic. Anonymous classes, so when you make a call like this, it basically makes an anonymous class inside of that call. So it makes like an object, which is just discarded as soon as it's made. So it will make a greeter bot, but it will make an anonymous class to create that greeter bot. Know how this actor manages the control of an instance variable. No concurrency guards such as synchronized or atomic integer on existence and actor instance processes one message at a time. I'm guessing like under the hood it probably does use some type of atomic reference though. Yeah, Java doesn't have async blocks, so I'm pretty sure it uses some type of atomic reference or some type of like reference counting to make sure that everything is asynchronous. Oh wait, presses one message up. Then no, that doesn't make. What I said doesn't make sense. I'm guessing there is some type of queue or something to make sure that it only processes one at a time. I think it might be this receive builder. So far we have looked at the definition of actors and their messages. Now let's dive a bit deep into power, location, transparency, and see how to create actor instances. In Akka, you can't create an actor of an instance using the new keyword. Instead, you create the actor instance using the factory spawn methods. Spawn does not return an actor instance, but a reference Akka actor type actor ref that points to the actor instance. This level in direction adds a lot of power and flexibility in the distributed system. In Akka, location doesn't matter. Location transparency means that the actor ref can, while retaining the same semantics, represent an instance of the running actor in process or on a remote machine. If needed, the runtime can optimize the system by changing the actor's location or the entire application topology while it's running. This enables the let it crash model of failure management, in which the system can heal itself by crashing faulty actors and restarting healthy ones. That's sick! An actor system is the initial entry point in Akka. Usually one actor system is created per application. The actor system has a name and guardian actor. The big shot of your application is completely done with the guardian actor. Guardian actor in this actor system is green main. That's it. It uses behaviors to bootstrap the application. Where is that? That is not there. That is on green main. Ah, here we go. Behavior. Okay. That's an abstract behavior, so that's where that's coming from. That's a behavior. Behaviors.sap. Here we are. This bit. Other actors are created using spawn methods and actor context. A greeter main that creates a greeter actor this way on startup, as well as a new greeter bot each time it receives a say hello world message. Say hello message. God. Nearly been half an hour, by the way, so I was definitely right when I was like, yeah, I'm going to be taking longer than this. Actors are reactive and message driven. An actor doesn't do anything until it receives a message. Actors communicate using asynchronous messages. This ensures that asynchronous means that it can happen at the same time. This ensures that the sender does not stick around waiting for their message to be processed by the recipient. Instead, the sender puts the message in the recipient's mailbox and is free to do the other work. So there is some type of queuing model. The actor's mailbox is essentially a message queue. I love how I say things, and it's like, oh yeah, next line, it just says it. With ordering semantics, the order of multiple messages sent from the same actor is preserved, but can be interleaved with the message sent by another actor. You might be wondering what the actor is doing when it is not processing messages, doing actual work. It is suspended state in which it does not consume any resources apart from memory, again showing the lightweight, efficient nature of actors. I wonder what it means by suspended state. Is it just chucked off of the... So what I'm thinking is sometimes some classes can be loaded into memory and then they can be collected by the garbage collector so that they're taken out of memory if they don't persist as long, right? Does it mean that? Or does it mean like it will just put that thread that it's running on to sleep and then just wake it up again when it needs to process work? That's what I'm wondering. Because if it's the thread sleep, then technically speaking, it doesn't consume resources unless it's running, right? But if it's being collected by the garbage collector, then you're just spawning new instances of the same class to handle new messages. So yes, it doesn't take up resources afterwards because it's literally just collected immediately, but you're instantiating the whole class again and you're making new objects each time a new message isn't there, right? So it'll be collected, you'll be awaiting a new message, you'll receive one, you'll instantiate a new object, and then you'll be processing objects while it's happening. So I mean while you're receiving that message queue, right? So I'm not sure which one it means. I'm gonna assume that it's gonna be the thread model, or like a different model entirely, because if it's like spawning new objects and just waiting for the garbage collector to just collect it away, that seems very inefficient. To put a message into an actor's mailbox, use the tell method on the actor ref. For example, the main class of the hello world sends messages to the greeter actor like this. The greeter actor also sends a message to acknowledge it has received the greeting. We've looked at how to create actors and some messages. Now let's review by looking at the main class. The Akka actor Quickstart object. So let me just open it. In Hello World creates actor system with the Guardian. The Guardian is the top level actor that bootstraps your application. The Guardian is typically defined with behaviors.setup that contains the initial bootstrap. Okay. Here below is the complete source code for the 3 classes that create the sample application. Okay. As another best practice, we should provide some test coverage. Testing actors. The tests in the Hello World example illustrate use of JUnit. Nice. By the way, I use JUnit at work. It is sick. I don't know if they're using Mockito, but JUnit is sick. They're using testkit JUnit. Okay, so they're using their own implementation of JUnit, which are... Oh no, they're also using normal JUnit. Is maybe they have like custom methods that can only be loaded if they load in JUnit and then their own resource. I think. Because JUnit with all these annotations that say that, oh yes, this is a test, how you should execute it, right? Like you can do that in JUnit with different annotations. I'm guessing this test kit in JUnit resource and test probe are being used here, and on this line. Because under test is the actual like thing that you want to execute, right? So this test kit's .spawn this and this are being loaded in by actor ref. Interesting. Test class definition. Support for JUnit is included by using the test kit. I need to stop doing that. This automatically creates and cleans up the actor test kit. To see how we use the test kit directly, see the full documentation. This test uses test probe to interrogate and verify the expected behavior. Let's look at the source code snippet. Once you have a reference to a test probe, we pass it to the greeter as part of the greet message. We then verify the greeter responds that the greeting has taken place. And here is the complete code. The example code just scratches the surface of the functionality available in actor test kit. The complete overview can be found here. You can run the Hello World application from the command line on IDE. The final topic in this guide describes how to run it in IntelliJ. But before we run the application, let's take a quick look at the build files. As you see below, the build files for Maven, Palm.xml, and Gradle build.gradle used in the sample simple sample project are very simple. Please refer to the documentation and the build tool of your choice for information. So this is just SBT to run SBT. Again, SBT if you don't want to use the bat. Palm.xml, this is just Maven, how you would build it in Maven. This is how you'd build it in SBT, and this is how you build it in Gradle. All of them are pretty much the same. And these two are just executables for SBT in case you do not have SBT installed. I'm pretty sure it will just, yeah, it will locate SBT on your system and execute it for you. So you don't have to, what's it called? No, it won't even load it from your system. And because it's packaged in the project, you don't need to have SBT installed. So you could use these to run the whole application. If you do like SBT build or SBT run, it will just execute this build.sbt. Gradle and Maven. I'm gonna keep the Gradle open because Maven is verbose. Gradle is a bit nice to look at. It just applies some plugins, which is basically like imports. It checks these repositories, so you want to just check Maven Central most of the time and Maven Local. dependencies are just saying that you want to grab this version of this library and you want to use it. Test implementations are just for like testing frameworks. So the difference is implementation would be you want to have these in your tests and in your production ready code. Test implementation is just for I only want this in my tests. So like there's no point in you putting JUnit as a normal implementation because you're not going to use JUnit when you're actually like running production ready code, right? You're only going to use JUnit when you're testing. So you only want it being pulled in when you're testing. Main class name is just saying you want to execute it from Akka Quickstart. This is in case it doesn't have a main method, but it does, so it should know it anyway. And then this run is just to say where to output your... Is that standard input? Yeah, okay. So standard input is just saying that you want standard input to go to system.in. And then I'm guessing you could do like standard output to either go to system error, system out, or another... Oh, what's the other one? System error, system out. Maybe system info or system debug? I don't know if those two exist though. I know they exist in SLF4j, like logger. I mean, like log4j, sorry. Now that some dependencies have a suffix in the artifact name, I'm gonna switch to the Gradle one because... Oh, it still does it, even though it's talking about Gradle. Oh, it's because of this. Oh, fair enough. Suffix is a Scala version. This artifact code is compiled for all artifacts must be compiled for the same Scala version so that you can't depend on... And, oh. Fair enough. That's a weird output. So if I click getting started, what's over here? Ooh, okay. Well, I'm using these, so it should be alright. This is more of like a... I would say if you want to like look behind the scenes, check this out, because most of the questions I'm asking are probably being answered here. But I'm going to stick with the normal ones. I mean the normal normal examples English has available. Anyway, I'm just gonna run the test suite because I want to see what it does. Gradle test. Cool. Just ran it. Nice. Anyway, thanks for watching. Hope you enjoyed the video. Like, subscribe, enjoy the rest of your day, and peace.